Bluetooth technology has revolutionized how we connect our devices wirelessly, but have you ever wondered how it actually works? Today, we're diving deep into the fascinating world of Bluetooth communication, exploring the engineering principles that make it possible for your devices to seamlessly share information through thin air. Let's start with a simple example. When you're listening to music through your wireless headphones, your smartphone is transmitting approximately 1 million binary digits, ones and zeros, every single second. These binary digits are assembled into 16-bit numbers that create the electrical waveform that eventually becomes the sound you hear. But how does this massive amount of data travel wirelessly between your devices? To understand this, we need to explore the fundamental principles of electromagnetic waves. Just like visible light, Bluetooth operates using electromagnetic radiation, but at a different frequency. While visible light has wavelengths between 380 and 700 nanometers, Bluetooth operates at wavelengths around 123 millimeters, corresponding to a frequency of 2.4 gigahertz. Think of it like this. When you look at a traffic light, you can distinguish between red, yellow, and green because each color has a different wavelength. Similarly, Bluetooth devices communicate by switching between specific wavelengths to represent binary ones and zeros. Your smartphone's antenna generates these wavelengths and switches between them at an incredible rate, about 1 million times per second. The Bluetooth spectrum is divided into 79 different channels within the 2.4 to 2.4835 gigahertz range. This division allows multiple devices to communicate simultaneously without interfering with each other. But here's where it gets interesting. Your devices don't stay on one channel. Instead, they hop between channels up to 1,600 times per second in a synchronized pattern known as frequency hopping spread spectrum, FHSS. This frequency hopping serves multiple purposes. First, it helps avoid interference from other devices operating in the same frequency range, like Wi-Fi routers and microwave ovens. Second, it provides a level of security since only paired devices know the specific hopping sequence they're using. Think of it as having a secret code that changes 1,600 times every second. The actual data transmission occurs in packets. Each packet contains 3 main components: an access code, 72 bits, a header, 54 bits, and a payload, which can vary from 136 to 8,168 bits. The access code works like an address on a letter, ensuring the data reaches the correct device. The header provides information about the type of data being sent, while the payload contains the actual information, in our music example, the audio data itself. But what happens if there's interference or a packet doesn't reach its destination? Bluetooth has built-in error detection and correction mechanisms. If a packet is lost or corrupted, the receiving device requests a retransmission. This happens so quickly that you rarely notice any interruption in your audio stream. The way Bluetooth encodes data for transmission is equally fascinating. It uses various modulation techniques, including frequency shift keying, FSK, and phase shift keying, PSK. In FSK, binary ones and zeros are represented by slight shifts in the carrier wave frequency. PSK, on the other hand, represents data by changing the phase of the carrier wave while maintaining a constant frequency. Let's talk about power and range. Bluetooth devices are classified into different power classes, with Class 1 devices having a range of up to 100 meters, Class 2 devices reaching about 10 meters, and Class 3 devices limited to roughly 1 meter. Most consumer devices, like smartphones and wireless headphones, are Class 2 devices, offering a good balance between range and power consumption. The latest Bluetooth versions have introduced significant improvements in data transmission rates and energy efficiency. Bluetooth 5.0 and later versions can achieve theoretical data rates of up to 2 megabit per second, while using adaptive frequency hopping to better avoid interference. This means better audio quality, longer battery life, and more reliable connections. One particularly clever aspect of Bluetooth is its pairing mechanism. When you pair 2 devices, they exchange secure keys and establish a trusted relationship. This process involves creating a unique link key that both devices store and use for future connections. The devices also remember their frequency hopping patterns and timing synchronization, allowing them to quickly reconnect when they come back into range. Bluetooth also supports different profiles for different types of connections. For example, the A2DP Advanced Audio Distribution Profile is used for high-quality stereo audio streaming, while the HFP Hands-Free Profile is used for phone calls. These profiles define how data should be formatted and transmitted for specific applications. The technology continues to evolve. The latest Bluetooth standards support mesh networking, allowing multiple devices to form interconnected networks. This is particularly useful for smart home applications, where numerous devices need to communicate with each other reliably. Looking ahead, Bluetooth technology is becoming increasingly sophisticated. New features like direction finding and improved location services are being integrated, while maintaining backward compatibility with older devices. The focus remains on reducing power consumption while increasing data throughput and reliability. Understanding how Bluetooth works helps us appreciate the complexity behind this seemingly simple technology. Every time you connect your wireless headphones or use a Bluetooth speaker, millions of binary digits are being transmitted through the air, hopping between frequencies, being checked for errors, and reassembled into meaningful data, all in real time and with remarkable reliability. The next time you're listening to music through your wireless headphones, remember that you're experiencing the result of decades of engineering innovation, making it possible to transmit massive amounts of data through thin air, invisibly and efficiently. It's a testament to human ingenuity and our constant drive to make technology more seamless and user-friendly. What aspects of Bluetooth technology do you find most interesting? Are you curious about any specific features or capabilities? Let me know in the comments below. And don't forget to subscribe for more fascinating explorations of the technology that shapes our daily lives.